Hi, so welcome back to the Virtual Azure Community Day. Suzanne is having a short break right now, so we have a new host, Mark Duiker. Welcome, Mark.
Thank you, thank you.
Our next session is from Callum Whyte. Callum is talking about how to deploy globally resilient websites. Hi, Callum.
Hey, how are you doing?
I'm good. How are you?
Yeah, I'm good. I've been enjoying the sessions throughout today.
Okay, great. So I see that you already are involved in organizing events and meetups, right?
Yeah, so I'm quite involved in the Umbraco CMS community. And I know that's something that Mark has also been involved in. So I organize a conference and some meetups and a social event as well. And I get to travel all over the world and talk at various events as well.
Okay, that's nice. And is Umbraco part of your next session as well?
It's not going to feature directly, but I mean, I use this in my day-to-day work with Umbraco, so it definitely applies.
Okay, it's a very awesome topic. I'm very curious to your session, so good luck.
Thank you. Okay. Okay, here we go. Hello, everybody, and thank you very much for taking the time to come to my session today. I'm going to be talking about deploying globally resilient websites or applications. As we just mentioned, my name's Callum. I'm on Twitter. You can reach me there. I tweet about all things .NET and DevOps and Umbraco CMS as well. I'm a Microsoft Developer Technologies MVP and also an Umbraco MVP. Because of my involvement in the community. Umbraco is an open source .NET based CMS. So primarily I'm a .NET developer, but I do work with various different Azure things as well. I speak at a whole bunch of events and I get to organize them too. And I'm a massive donut fanatic and the lockdown's not been too kind to me because of that. So what are we going to look at? Hopefully the takeaways from this will be how you can go away and make your hosting setup more resilient. You don't have to be working on a truly global scale for this talk to be valuable. There should be some takeaways. Also some considerations when scaling an application. It's very easy to build something that maybe works on one server, but how do you build something that works on multiple or even a global scale? And then how you can do deployments like a pro, some various different ways of handling deployments. Things you may not think about if you're not used to dealing with high traffic and high uptime systems. Finally, whilst of course this is the Azure Community Day, I will be talking about things in an Azure context, but I will make some references across to AWS, Cloudflare, some other services where there's a comparable thing available, because I know not everyone is using Azure. So what is the challenge? What exactly are we trying to solve here? I thought I would set a hypothetical scenario to set the scene for this talk. The goal here, I've been tasked with creating a social app, something a bit like Facebook Messenger, Twitter, or WhatsApp. It needs to have a scalable backend, and we're going to have a mobile app of some sort that will be powered by this backend. It will allow users to manage their profiles. So we've got some kind of authentication element there. We've also got a way for them to chat and a way for them to post status updates. The exact behavior of the app doesn't really matter. What's important here is this is quite a write-heavy application. So users are going to be consuming large amounts of content from, say, the statuses that their friends that they are following have posted, and also producing content by posting it, updating their profile. The key is this application must be fast and it must work regardless of where a user is all over the world. This could be someone in Australia, someone in the UK. They should have the same experience. Oh, and of course, it has to run on Azure. So what are the different approaches that people can use for scaling applications? I guess the most typical scenario that you might do kind of at a basic level would be scaling with load balancing. So you would have a load balancer that you would spin up inside a data center, and you would sit servers behind that load balancer. So when you need more resources for your application to perform better, you can just add more servers and add more servers into the load balancer. That works fine for small systems. And in fact, before Azure really came about, this was the way we would do things. Similarly, when we wanted to do a deployment, to ensure that our front-end users weren't impacted, we would perhaps remove a server from the load balancer, do our deployment straight to that server, and then reintroduce it into the pool of servers. Similarly, failure works in the same way. So if one of the servers in our cluster was to fail, it would be removed from the load balancer, fixed up, and then put back into production. This is quite a resilient setup, but it does have some challenges. So when you're doing a deployment and you do take a server out of your cluster, you're reducing your capacity. So if all of your servers in your cluster are running at a pretty high capacity constantly, you're going to put your application under some strain. So that requires a bit of planning. Furthermore, the load balancer itself is actually a single point of failure. So we've discussed what happens if a server fails, but what does happen if a load balancer fails? They're generally pretty resilient pieces of physical hardware in a data center, but yeah, hardware fails sometimes. Another thing would be the servers being all in the same place. If we're going to put our tinfoil hat on and really try and think about this from this needs to be a watertight system. There's obviously conditions in which those servers could fail, such as an earthquake or a natural disaster, or something more common like a power failure or a connectivity issue. So if your data center where all of those servers are living was to experience a loss of connectivity, your site goes offline. There's also sticky sessions, which most load balancers nowadays handle pretty well. This is the idea that a user and their session should be kind of persisted to one server at all times. This is mostly just a setting in a load balancer, thankfully, nowadays. Okay, so the single point of failure thing, that's not great. So the way that people tackle that is by having replicas and failover. So here you would have that same setup we've just discussed. Let's say region 1 here. Region 1 has that same load balancer and it has multiple virtual machines behind it. That region may fail, and that's okay, because the site reliability team or the DevOps team will maintain a replica setup in another region. Now, this other region would hopefully be in another physically, geographically different region. Therefore, if there was a natural disaster or something, you could move traffic over to that other region. Similarly, it would hopefully be in a completely different, hosted with a completely different data center provider, or at the very least using some different resilient setups. So they may have failover for their the connectivity providers, or they may have backup power. The way this would generally work is you would spin up effectively the exact same infrastructure in 2 different regions, and you would maintain those in sync. So you may do a deployment to region 1, whilst region 2 is currently serving the traffic. Then when you're happy that the deployment in region 1 is successful, you may switch your traffic to, say, point over to region 1, sorry. This means that you can pretty safely and reliably test your infrastructure, make sure it's working, and if something does go wrong, you can switch it back to completely clean new infrastructure that you do know is working. Furthermore, if an issue occurs, you can pretty easily switch this over. These switches are generally done by DNS though, and the problem with DNS, as I'm sure everyone who's ever worked with DNS knows, is it gets quite aggressively cached. Sometimes it's a bit unpredictable. So if you do need to switch something over in a hurry, this might cause a problem. Furthermore, there's absolute equal chance that, I don't know, both of these regions fail. Another problem that we can come up against with these multi-region setups is how you actually keep things in sync. So if you do a deployment to one region, you have to make sure that that deployment is reflected in the other region at some point. Because if you do ever need to switch over and you find that one region is completely different to the other, your users are going to run into problems. You may have features missing from your system. So yeah, if region 2 here fails, we can easily cut region 2 off and the traffic goes to region 1 now instead. Replication is an interesting one because this is all, failover is all well and good when you have infrastructure, but when you're actually talking about data at play and how you make sure that user data is synchronized between regions, that gets complicated. So let's say in this scenario, we have a SQL pool that lives in region 2. We also have some file storage that lives in region 2. Now that is what's powering our application. Of course, we're doing our best DevOps practices and making sure that our deployments are synchronized across to the region that's not currently in production. But how do you handle that data? If you were to just right now have region 2 fail and region 1 have to take over, well, if it's a total catastrophic failure in region 2 and that's where our data lives, how do we make sure that that data is also available in region 1? Of course, we have to have copies, and that creates some problems. Region 1 would have an identical SQL server and an identical storage server, as well as the identical application servers. And in this case, you would have to have some sort of mechanism for synchronizing that data. In the scenario that I painted at the start, which is a high throughput read and write application, we would need some form of SQL replication here. That would be baked into SQL Server, and it can automatically replicate between the two. You'd have a primary, which in this case would be in region 2, and the primary would then fail. So we'd switch the primary database to be the secondary, which was therefore living in region 1. The same would apply to the storage. Now, this isn't a hugely alien concept either. I'm sure people are aware of this sort of setup and the faults and the downsides that it can have. And in fact, this is exactly how the cloud works. We have multiple regions and availability zones within cloud providers' networks, and they do all of this kind of for you. So you can swap out here VMs for being Azure Web Apps, and you can swap out the SQL database for being SQL Server for being an Azure SQL database, for example, storage for blob storage. All of these same principles apply. This is what's going on behind the scenes. So that's all great. You have two different regions set up. You can handle deployments to each one, and you can choose to switch between one or the other. Now, of course, there's sometimes a case where you may need data in different physical locations, and that could be for various reasons. It could be for, as I mentioned before, natural disasters that occur. What if the US lost all internet connectivity? We'd probably have some bigger issues to be dealing with, but it's a valid concern for some companies. What if both of our data centers get wiped out? Can they put them in further physical, put them a further physical distance away from each other to mitigate that? And secondly, from a kind of data protection point of view too, sometimes you may need to store certain users' data in certain locations. So we need to bake some geographical element into our systems. I think probably the most common thing that we hear when we talk about geographically dispersing our data is a content delivery network. This is the idea that you have servers closest to your users that store a cache, a copy of the content that you are serving from your primary server. So in this case, for example, we have an origin server that lives on the west coast of the US, and we can then see that we have individual nodes of our CDN, and they live across the world. And then when a user in, for example, Australia requests content, they get served a cached copy from the CDN in Southeast Asia, rather than having to connect all the way across the Pacific Ocean to the west coast of the US. This is great. It speeds things up a lot. And for things like static content, images, CSS, JavaScript, this is brilliant. This is what it's designed for. But it just isn't designed for dynamic content. So where we're building this flexible application with a lot of reads and writes, it's just not going to work. There may be some things that you can cache reliably on a CDN because they're going to change very infrequently. But for user updated content, it's not really an option. And again, there are scenarios where if your origin server fails for a long, long time, your CDN and your site users can still experience issues. Let's say you're only caching your CSS, JavaScript, and images, and every other dynamic request still goes to the server. Well, the server's going to go offline, and then you have the same sort of issues. Similarly, the CDN caches content, and it has to have access to the server in the first place to reach it. This doesn't mean you could just deploy your site on a CDN or your application on a CDN and let it work. You have to have some kind of backend server there constantly. So this isn't hugely globally resilient. It just helps with performance. I'd say this is probably the go-to Azure solution for globally distributing your application. Now, you see here we've got a European region and a North America region. Those could live anywhere in Azure. It doesn't really matter. And those setups would probably be as close to what we were just discussing before, a resilient failover setup, so that if an app service was to fail, for example, you can automatically fail over to something in another region or to a backup. The same goes with your storage. It should be replicated. Your database will be there, and it will be stored in a large cluster, so if one server fails, it doesn't really matter. What Traffic Manager does is it lets you automatically route traffic to the right server. And you can define what constitutes the right server, whether that is the closest one to the user or the most performant or the one that's currently available if one was to go offline, for example. The way Traffic Manager works is it is an anycast DNS service. That means they have servers deployed all over the world. When a user in South America makes a request to your website, it hits the DNS of Traffic Manager, and Traffic Manager is asked, where should I send this user? They have a set of rules there to route that user to the right place. Now, that's all great, but as we said, DNS fails. This is a DNS level routing service. That means you've still got the downsides of caches and things not quite updating. So you still have potentials for failure there. And of course, Traffic Manager can fail too, though it is a highly resilient, globally deployed service, and it's used by Microsoft very widely. So I doubt it's got that many issues. Now, of course, there's downsides with all of these solutions, and we probably need to come up with something better. One of my absolute favorite Azure services nowadays is something that has existed for years but has only been public for a couple of years. This is something called Azure Front Door. Azure Front Door is a globally deployed gateway. So unlike Traffic Manager, where it's doing all of its routing at a DNS level, this is a service that lives on, again, hundreds of nodes all over the world, but actually executes at the edge, not through DNS. So what is Front Door? It's, as I said, a globally deployed gateway. It allows you to create advanced routing rules. And by advanced, I mean this is effectively anything you could do with IIS URL rewrite rules. It's fully flexible. You configure backend services that live behind the gateway, and for a specific path, they serve requests. Optionally, you can equally bake in CDN and a firewall. So here with Front Door, Microsoft converges several of their services, popular services, their CDN and their firewall, and makes them all available under one umbrella, which is really nice. You can do SSL termination at the edge, so you don't have to worry about that slightly CPU expensive decryption of SSL certificates at the origin server level. You can have everything encrypted up to Azure and unencrypted inside, or if you choose, encrypted again to the server. And the most important thing, and I think the key difference between Azure Front Door and Traffic Manager or Application Gateway are that this routes everything internally on Azure's network. That means it's super fast. Now, that might be a slightly weird point, something that you weren't quite expecting to hear. Why would this be potentially faster than another solution? Well, let me explain. So Microsoft has a humongous dark fiber network that runs throughout the world. This is effectively cables that have been laid under the sea, across land, wherever, to connect Microsoft data centers. What that means is they can very efficiently move data on their own network. Unlike using the public internet, which gets congested and you're contending with everyone else's traffic, Microsoft's own network actually allows them to, it's kind of like a super speed highway. They can move things as fast as they need to. I read something saying this is effectively as theoretically fast as it could possibly get within the realms of physics. So it's a truly, truly fast network. Now, if a request came into an Azure Traffic Manager service, what would happen is, let's say the request comes in here in Australia and our server lives here in the UK. What would happen is the request comes in from a user in Australia, it hits Microsoft's Anycast DNS network in Australia, and it goes, okay, I need to route you to a server in the UK. That posts back to the user effectively and says, you need to go here. And it does all of the DNS lookups and the hops across the world to get that request over to the UK and that server that it needs. That's fine. It works well. However, with Azure Front Door, that request happens internally in Microsoft's network. If they've worked out the most efficient way of that request getting to London is across the Pacific, across the US, across the Atlantic and into London, they will do that for you, and they'll route that through the internal network, through their internal fiber network. This means that you have a significant increase in kind of DNS performance, especially if you're dealing with Azure resources. But it gets better because you may decide to not use Azure resources. You may decide to be using, for example, an IBM data center somewhere in Texas. Well, this same request in Australia would still be routed through Microsoft's internal network, but it would leave the point of the network almost physically closest to where that data center lives. So this user in Australia may still be routed through the internal network over to the US to Texas, leave in Texas, and within like a 1 millisecond hop be in the IBM data center. Whereas with something like Traffic Manager, that request could go anywhere all over the world before it actually hits the correct data center. Of course, all of this is fantastic when you've got multiple servers. So this means at any point of presence in the network, Microsoft can work out what's the quickest way, the closest server to get this request serviced, meaning that it can be kind of dynamically updated. If a server fails, let's say our server in London fails, but a user requests something in London, the network will automatically work out where it needs to be routed, what's going to be the best way to do that. So for our needs of building a truly global and resilient application, this is a pretty good tool to be using. And thankfully, it's really, really easy to set up. I'd like to show you quickly a little sneak peek at how this would actually be configured. So you'll see here I've spun up a couple of test resources. I've got 3 different regions that I've spun up, and in fact, I've actually got a 4th. So I have a simple service here. This is just an Australian app service, and it's serving the name of the server that it's running on. So this is from the Australian Central region on Azure. We have a similar one for the West US region, just an app service serving a very simple file. And furthermore, we have a UK South one. For me, that would be the closest right now. I've also spun up, just for a laugh, a service on AWS in Ireland. This is just sitting on an EC2 instance. We have a static HTML file sitting there. It's going to be pretty fast. I've also then created an Azure Front Door instance. When I open Azure Front Door, the configuration is very, very straightforward. It gives me a front-end host name. This is a host name that I can point my DNS to, but I can also serve my traffic through as well. They have a really nice experience through the Azure portal for designing how you want your front door gateway to work. This works by defining front ends, back ends, and rules. A front end would be the host name at which, or the CNAME at which a request enters the network. This is deployed globally across all of the Azure network. Similarly, we then have a backend pool, and a backend pool is mapped up to a routing rule to say if any of these paths, any of these rules, these conditions are matched. For example, here this is just a catch-all rule. It will route that to this selection of pools. So in this case, we're saying that should go to the default pool that I've created. We can also configure some more advanced things like, does this require HTTPS? Can we do the URL rewrite rules like I mentioned before, and some caching, which we're going to come back to in a minute. A backend pool is effectively saying these resources, these endpoints are available to serve these requests. And Azure Front Door will automatically go and health check each of those requests at a definable interval. I've set here 5 seconds, which is the minimum, purely to hope that this demo can be, you can see some results a bit quicker. And you can define how many times a request should fail or succeed before it's taken in or taken out of the pool automatically. What kind of latency is an acceptable level? I've vaguely left this as the defaults. You'll see for now that my Azure Front Door is servicing the Australian data center and the West US data center. And because I've set the weight of each of these to be 50-50, it's equal. It's going to serve me to whichever region that Azure thinks is going to be fastest. Now, before I demo that, I'm just going to add another pool, but another backend, because it would be interesting to demo this. I discussed before how I've got this Ireland AWS site spun up, so I'm going to actually add that one into my resources. When you go to add a backend, you can see the wide variety of services available that Azure already integrates with. So if you've got app services, I can select an app service and then automatically select a resource that's already in my account. For example, one of the Azure Community Day resources I spun up. Similarly, you can write it off to storage, application gateway, API management, a whole bunch of things. You can even redirect this to a custom host. So in my case, I've created this AWS host and I want to serve my traffic from there. Let's re-add that and update it and save. So the process of updating the backend does take a little bit of time because it's got to propagate that change across, hundreds of nodes across the world. There's a purge mechanism in there as well for making sure you clear out any of those the caches that are living on those services. Generally, within about 5 minutes, we see an update, but it's sometimes a bit less, it's sometimes a bit longer. You'll see here, I've actually got my apps, they refresh automatically every 2 seconds, so we'll hopefully see when that's completed. Right now, the Azure Front Door Gateway is servicing requests from West US. For me, where I am in London, that is the most performant place to be serving from. However, I could do something a bit cheeky, and I could go into my West US instance, and I could perhaps make it really slow. So I'm going to put a thread sleep in there of, 10 seconds, shall we say. That means every time a request gets sent to the West US region, it will have to send me to the next fastest or next available service. So now I've done that, hopefully within not too long, Azure Front Door is going to detect, this is taking longer than it should, and it will start servicing the requests from that West Australia region that we've got in there as well. Whilst this is happening, I'm going to proceed with the slides, and we'll come back and check on this in a minute. Now, this all sounds kind of too good to be true. You've got really nice visualization of where all of your backends live. You can really nicely integrate with Azure and even have like a multi-cloud strategy in there. So you could have half of your services on AWS in another region if you so wanted to. It's really cheap as well. So this is kind of typical data transfer pricing from Azure, and very, very minimal pricing for things like the routing rules. Similarly, you can bundle CDN and WAF in with it too. I mentioned that earlier. The pricing for that's basically just the same price as if you'd ordered the service directly. So it's a really, really nice tool. I said as well, I promised to shout out any other vendors if they existed. So Cloudflare have a really good offering for this, and it's a pretty close competitor, I think, for Front Door. It's called Cloudflare Argo. The thing that Cloudflare has got on almost any of these companies is they have a huge number of network locations, so they can deploy all of this globally. I think another benefit here is they're not an infrastructure like a hosting provider. They're not an infrastructure provider. It's purely a service. So you could use this and use Azure and AWS and a whole bunch of other networks all over the world, and you're kind of decoupling. It's yet another bit of resiliency, not having a dependency on one specific company or vendor. AWS have Global Accelerator, which does pretty much exactly the same sort of stuff as Front Door. Oh, okay, that shouldn't have happened. Okay, so you see now we've actually reliably switched over to the Australia Central region because West US is officially down. It's still, for some reason, it's still trying to propagate my my change there for when I added the AWS region. Maybe it doesn't like AWS today. Oh no, it seems to have saved it. So perhaps we could just purge the cache and hope that that actually will. Okay. Nope, looks like the demo gods aren't quite on our side. In theory, because that service is much closer to me than Australia, now I would see the Ireland data center being served. I just wanted to quickly also show some of the flexibility at which you could use Front Door. So perhaps you want to serve some requests from, or all of your requests from all of your servers, but maybe just for admin purposes, you only want to serve certain paths from one or two specific regions. Or maybe for a data sovereignty point of view, you have specific URLs which should only live in a specific country. Well, you can do that pretty easily. So here, let's say I add a backend pool called admin, and let's say I can also point that to my AWS service. Where's it gone? There we go. So that's another backend pool that I've created. It's using the same settings as everything else was using before. I've got this rule that says when any request comes in, route it to this path, but maybe I want to do something slightly different. So when I say this is my admin route, and anytime someone goes to /admin/something, I then want to use the admin pool. That means it's only going to go to the admin backend pool that I've configured. I wonder if this is going to save now, or is it going to fail? It's going to fail. Okay. What would happen? You can see here, if I go to /admin, that gives me a 404 because it's currently routing to Australia, which doesn't have /admin. However, this service does have /admin. So my backend pool would respond to /admin, and I would then only service traffic to that path from that server. Okay, so I promised we'd talk about deployments and ways you could handle these. So we've kind of demoed a setup for how you would deploy, how would you route users and handle your application at scale and globally distributed. But how do you deploy to that? Well, there's a whole bunch of options. You could just deploy straight over the top of each application that you've got running everywhere in the world. But that means every time you do that, the whole application goes down. But maybe that's not such a bad thing, because Azure Front Door will automatically health check that app. And if it realizes, okay, that app's gone offline, it will automatically take it out of the pool for you. Alternatively, you could deploy each app one by one. And that means that you've kind of got a far more rolling effect across your application. This is more similar to the approach of you take one service out of the load balancer, you do the deploy, and you put it back in. Again, Azure Front Door takes care of doing that. And the final thing you could do is more of a staged approach. Anyone that's familiar with Azure will know that there's the facility of slots, and slots allows you to create an isolated, separate environment where you can deploy your changes and then automatically switch them over. What we're effectively talking about here is a multi-region simultaneous, create a slot on every single app service, test it all in another Azure Front Door instance, and then when it's ready, swap them over and promote them. You can do that, thankfully, because there's a really nice endpoint in the Azure CLI where you can create this pretty easily. So, for example, here I could say I'd like to create a new backend pool, and it should point to the VACD West US Azure service that I've created, add it into the service, and away we go. The same goes for deleting a service. So if you wanted to remove a backend from your pools, you can do that pretty easily. Because this is here, we can do it directly through the Azure DevOps pipelines. If you wanted to use GitHub Actions or TeamCity or some other CI service, you could absolutely do that. The principles are going to be very similar. Let's first start by looking at what a rolling release would look like. This would be a way of deploying kind of one time, and when it's done, when you've done one region, move on to the next. And here you would remove it from Front Door at each step, do the deployment, and then when it's successfully completed, re-add the region into Front Door. You'll see I've created 3 steps in my deployment, my release pipeline. You've got a West US deployment group, you've got a UK South one, and an Australia Central one. The steps are the same across each of them. Here we disable the pool, and we then might run a script or something to create our resource in that region. We then do a very typical app service deployment. At this point, you're okay to do that because the app service does not live. It's not in Front Door. It's not going to be served from there. And then finally, when that deploys successful, we re-enable it, and off you go. The same applies to the UK South one. It's a delete and then a re-addition after the deploy, and the same for Australia. So this is a nice way, but the downside is if say I don't know, West US succeeds but the UK South one fails, you end up in a position where your application has some level of deployment. You've got one region with the deploy successful and another without it successful. The alternative would be this staged release. And what we could do is we could stage each change by region. So you could say, I'm going to create a test environment for the West US region. What this will do is it deploys to a brand new app service. I've here got a variable called for the slot. So I think we look in my variables, it's called Canary. So this is going to create a slot on this West US server, this West US app service called Canary, meaning I can test that. It then adds the West US Canary resource into my Front Door gateway, and I can test that. Once that's done, because this is not able to trigger without an approval, you go, yep, West US looks good. I'm going to roll out UK South, Australia Central, and that will all be the same. And then, as a final step, you go, yep, we've tested all the regions, we're happy, let's go. You can switch the backend pools out. So you can say here, I want to promote, West US, UK South, Australia Central, and make those part of our Front Door backend pools. And that's how you'd get up and running. Okay. We mentioned data a little bit earlier on, and this application that we're trying to build here is supposed to be a write-heavy application. How do you handle database writes at scale? That's going to be a challenge. Now, this would be a typical way of handling replication of databases in Azure. Azure, baked into Azure SQL, offers database replication, which is great, but database replication itself has some constraints. If you've got a hugely write-heavy application, this is going to, maybe some of the replicas will take a little bit of time to catch up, and then you're going to end up with some problems. Similarly here, you have to have you can have a primary database which handles your writes and some reads, and you can have up to 4 secondary databases. Those are copies for read-only of that primary database. But if you need anything more than 4, you're a bit stuck. If you wanted to deploy this to 50 locations all over the world, that's not directly possible. You actually have to do something a bit weird with chaining secondary servers. So you could create a secondary and then say you want to make replicas of the secondary. And you can just see how as a kind of a pyramid, a trickle down of the data, it's going to take quite a while for you to replicate that all out to all of the services. Similarly, if your primary server fails, well, it fails. Your application goes offline. Through the portal, you can go in and say, I want to make this secondary server now the primary, and it will work all of that out for you, but it's going to take some time and it's a manual step. As far as I know, there's no way of automatically doing that. when a service goes offline. And in honesty, it would cause some chaos if it did automatically just do that. So Azure SQL may not be the best solution for scaling this. Also, if you don't have a service that's like located directly where your servers are, your app services are, it's going to be a bit slower. So as an extreme example, if we did do a database call from Australia to a database living in the UK, it's going to take far longer than a database that lives directly in Australia. If we can't replicate the data that far, we're still going to end up with a kind of somewhere in the middle. Calling a database that lives in the west coast of the US for someone from Australia is going to be slow. Is there a better solution? Well, a really nice solution is actually table storage on the Azure Storage Service. People don't always think about table storage as an option, but it's pretty performant. It can store a large quantity of data, and it can be geo-replicated-ish. There's a caveat to that, which is it's geo-replication within a region. So if you need resiliency, this is a great way to do it. You can use the same APIs, vaguely the same APIs as you can use with Cosmos DB as well. So from a scaling point of view, if you wanted to later shift off this and onto something bigger, you shouldn't need to rewrite much code. The benefit of table storage is you can literally deploy something equivalent to a SQL table in storage, and it will be available, and it's pretty damn fast. The downside, as I said, is that replication. You can't easily geo-replicate table storage. It has to be within one region or something similar. And I think it will only do the original and 2 replicas. The solution that I would choose if I was presented with this problem would be Cosmos DB. Now, Cosmos DB is literally designed for exactly this purpose. You can have Cosmos DB is already globally distributed. So if I want to say I want to replicate this across every Azure region that is available, you can do that. You'll pay for it, but you can do it. You can go into the portal and say, I want to enable replication, and choose the locations where you want to replicate it. That means that Azure kind of takes care of all that data replication stuff. And in my experience, it works pretty well. There's another thing that this has got over the blob storage and over Azure SQL, which is that it can be multi-region writable. So you can have writes in Australia and writes in the UK, and they would happen on the same Cosmos DB instance that is replicated, and eventually that will all get synced up, which is really impressive. And for an application of the kind of scale that I was describing at the start, it's pretty much perfect. As I said, through the portal, you can choose where your services live. Now, maybe someone from Microsoft can confirm this, but I believe it works in a very similar way to Azure Front Door as well. So it will automatically check when you try and post some data off to Cosmos DB, it will automatically check which is going to be the closest, most performant available region for you, and it will use that region to service your request. If one of them goes offline, that's not a problem. If you've got multiple primaries, again, that's not a problem, because one primary can go down and your whole system can keep running smoothly. Let's talk about caching. Caching is always a challenge in every application. There's this famous quote by Phil Carlton who says there's only 2 hard things in computer science: cache invalidation and naming things. There's the variation of that that's cache invalidation, naming things, and off by 1 errors, which I really enjoy. But this is true. Caching is difficult, and caching at scale is even harder. In fact, we just saw a minute ago with configuring Azure Front Door, having to propagate changes to hundreds of servers is a bit of a challenge. The cache invalidation is going to be no different. If we've got 50 servers all over the world, we're going to need a way of managing those caches that those servers have. Whether we're doing caching at a delivery level, like the Content Delivery Network does, or maybe at an application level, caching certain things in our application for performance. I guess a typical way of doing this would be having using Redis cache or using an output cache like a CDN. So Azure Front Door does already include Azure CDN, and you can enable that directly through the portal, I'll very quickly show you what that would look like. So it's as simple as going onto a route and saying, yep, I'd like that cached. And you can say the same things you would normally set for CDN. Yep, this should be cached. Ignore a query string, that sort of stuff. Do you want it compressed? It's pretty nice. And you can also customize the cache duration. So that gives you enough flexibility. You here might want to say certain API endpoints, for example, we're going to cache those for 5 minutes. For other things, you could just bypass the cache completely. Azure Front Door, because of this fantastic pattern matching and the rule-based engine, allows you to create such granular configuration there that it can be hugely powerful. Then there's Redis. So Redis is a hugely popular and open source caching service, and you can deploy that either on Azure or onto servers that you manage. Azure even offers on its Redis Cache Premium tier geo-replication. So this sort of gets around the idea of if you had one central cache, you've still got the same problem of it takes a lot of time to read data before you service it. Here, you could actually have the cache living alongside your service, your app service. The downside of Redis cache is it's really, really, really expensive. So every time you add a replication link to any of these cache instances, you're effectively doubling your Redis cache cost, which for a minimal, like an entry point cost is still pretty high. This will end up costing you a lot of money, but it's going to be very reliable. So that is an option if cost is no object. I thought I'd put this in here. So a way that I've handled this in the past, and actually a way that quite a lot of systems handle this, is by having their own cache and validation mechanism, some cache event handlers, if you will, so that when caches need to be purged on remote servers, a message can be broadcast that says we need to clear those caches out. I mentioned at the start I work with a CMS called Umbraco. Umbraco does this in a very similar way. The idea would be you could manage your own cache and purging your own cache. You're already paying money for memory at the server level, the app service level, where you're hosting your application. Well, if you wanted to have a cheaper way of caching stuff, you could use that onboard memory through either the memory cache or the runtime cache in C#, for example. The way it would work is you would add an instruction onto a queue to say cache this or purge this from the cache. And then on each of your application servers, you'd have an event that gets fired whenever one of those instructions is put on the queue. That queue could live in Azure Service Bus, or it could live just in a database table if you wanted. An example of how that would look using Service Bus, for example, would be as simple as you open a connection, you register a handler that takes a message and then does something with the memory cache. And that is a cheap way, I guess, of handling cache purging globally. So I thought I'd just share a couple of really helpful resources for people that have been interested about what I've spoken about today. There's a great video from Azure Friday where they demo getting started with Azure Front Door. I highly recommend watching that if you want to learn a little bit more and about how it works internally. Similarly, Cosmos DB replication is a much broader topic than I've been able to touch on today. There's a great Azure documentation page about that. And finally, Azure actually have on the website a great section about building resiliency into your applications. And it discusses a lot of the points that I've discussed today, as well as some more service-specific ideas. So go and have a look at that if you're going to be tasked with doing something similar. And with that, I say thank you very much. I'm on GitHub and Twitter if you want to keep in touch. Thank you.
Okay, thank you very much, Callum. Personally, I didn't use Azure Front Door yet, so I learned a lot from your session already. Really appreciate it. I really like that you talked about the distinction between the static content and dynamic content, and sometimes caching is very useful and sometimes it's not. So it's very good, and also managing your own cache for a solution for that. I don't think a lot of people do that, so that's a very good tip. I also really appreciate that you mentioned table storage, because I think that type of storage, well, Is my audio still muted? It's not on mute. No. Can I continue? Or? Yeah? Okay. And because data storage it exists already for quite a long time, and I think a lot of people need either forgot about it or really don't value it already. So thanks for mentioning that.
I think it's the like a dark horse service that people maybe just storage services. It's for files and images and
exactly.
That sort of stuff. It can do a hell of a lot of things, and it's very cost effective and very cheap. So I don't see.
Exactly. Yeah. No. Very good point. Thanks. And I have one question myself. So, do you have any tips actually to test for resiliency? How would you go about that?
Could you repeat that? Sorry.
Do you have any ideas how would you test for resiliency?
Yeah, absolutely. So I think there's, whilst I've not necessarily done this myself, there's tools out there that are very helpful for this sort of thing. You have services like Lowlands.Community let you load the system, and also it's like Chaos Monkey from Net, so if you're running rather than maybe on Azure, if you're running Kubernetes, you're running those everywhere. Chaos Monkey there take services out of action and whilst performing tests at a kind of global scale and make sure your requests are not dropping, that sort of thing.
Cool, thanks. All right. I don't have any more questions. Do you have a question still?
No, I don't have any questions. It was a really interesting presentation. Thank you for that.
Thank you.
Awesome to see Azure Front Door in action. Really cool service. Yeah. So we're out for a short break now, and we will be back in a bit with Maarten Goed, who's going to give us an overview of Azure Sentinel.
Excellent. Okay, see you then.
Cool.
Hi.
大家好
Namaste.
Servus.
Hi.
Hi.
Bonjour.
Yassas.
Hi.
Hoi. Ik ben
I'm
Floor.
Ryan Stropik from Austria.
日本からこんにちは。私は不破孝之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schot uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, ¿cómo está? I'm Ruby Jane Cabagna from the Philippines.
Hola.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Charlotte from France.
Hello, I'm Ruth from France.
שלום, אני ערן ספילר מישראל.
Bonjour, I'm Olivier from.
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.